In this lecture, we're going to talk about the concept of conjugate acid-base pairs. So whenever we have an acid that donates an H plus ion to a base, a new base and a new acid are formed. So for example, let's look at the reaction of acetic acid and water. So in this case, our Bronsted-Lowry acid is our acetic acid, and our Bronsted-Lowry base is our water. And that's because this guy has an extra H ion. It donates that H plus ion. And this guy has a lone pair of electrons on its oxygen, and it has the potential to gain a proton. So this is our Bronsted-Lowry base. Now when they react, this guy, our acetic acid, loses an H ion, while this guy, our water, gains an H ion. And that means if we look at these guys, this becomes our new base, our new Bronsted-Lowry base, because it now has the potential to gain an H ion, because it has that electron pair on the O atom. This guy now has an extra H ion, so it has the potential to donate one. So this guy becomes our Bronsted-Lowry acid. So we see that this statement holds true whenever we have an acid that reacts with a base, a new base, and a new acid are formed. So let's define conjugate acid-base pairs. So a pair of molecules or ions related to each other by the loss or gain of a single H plus ion are called conjugate acid-base pairs. So let's go back to our above system. So we have an acid loses an H ion, becoming a base. So this acid and this base are the conjugate acid-base pairs. Likewise, this base gains an H, becomes a new acid. So this base and this acid are the conjugate acid-base pairs. So whenever we have a Bronsted-Lowry acid reacting with a Bronsted-Lowry base, we will always form a conjugate Bronsted-Lowry acid and a conjugate Bronsted-Lowry base. For example, let's look at another reaction in which an acid, a Bronsted-Lowry acid, reacts with a base, water. What will happen is this has the potential to gain an H, so it will give off the H, and the lone pair of electrons on the base will take that H, forming our new conjugate acid plus our new conjugate base. So this acid and this base are conjugate acid-base pairs. And this base and this acid are conjugate acid-base pairs. So notice that one member of a conjugate acid-base pair is always found on one side, while the second member of the conjugate base pair is always found on the other side of the equation. You'll never find both members on one side. For example, this guy and this guy are found on different sides, and this guy are found on different sides. Just like this acid and this new base are found on different sides, and this base and this acid are found on different sides. So this always holds true. So for example, if someone asked you to find a conjugate base of some acid, you would simply take away an H from that acid, and that would be your conjugate base. Now likewise, if somebody gave you a base and asked you to find the conjugate acid, you would simply find the conjugate acid by giving or adding an H to our system. So for example, if someone said that our acid is this, and you need to find the conjugate base without knowing what this side was, you simply subtract an H. Likewise, if somebody gave you this and said this is our base, find the conjugate acid, you simply add an H and you will get your conjugate acid.